Okay, here's a problem. This problem has actually two batteries and two resistors, and it says find the current through both resistors. This one and this one. So I don't really care about that current, although there are three currents. Okay. So in this case, there's two things that we have. We have the loop rule, which says the change of potential, around any loop is 0. And then we have the junction rule. I can't spell right now. And that says I in equals I out for any junction like this. So in this case, I actually have just two junctions. I have this one, I have one. I have this one and this one, but they're actually the same thing. So the first thing we need to do is pick some currents. I'm going to call this I1, and don't worry about the direction. If you're wrong, it will come out in the end. I'm going to call this I2, and I'm going to call this I3. So if I do my junction rule right there, I'm going to get I1 equals I2 plus I3. Because the current coming in is I1, the current leaving is I2 plus I3. And if I did it over here, it would just be the reverse of this, which gives me the same algebraic equation. No point in doing that. Now I actually have three loops here. I have this one, I have this one, and I have this one. And I need two more of those loops because I need three equations to solve for three unknowns. So let's just use this. I'm going to use this loop right here. And then I'm going to use this loop right here. Okay, and you can do it any way you want, but I have a little bit of foresight here to see what might happen. So let's start right here and go around. So if I go across the resistor this way, I'm going in the opposite direction of the electric current, so it's going to be a positive change in potential. So I'm going to get negative I2 times 10. And then I come down here. Now I'm going from the positive side to the negative side. I get minus 3. And you'll notice right here, this equation only has one variable in it, so I can go ahead and solve for that. But I'm not going to. I'm going to go up here. I'm going to do this loop. So I'm going to start right here, and I'm going to go this way. So now I'm going in the same direction as I1. So I get, wait, I said plus. That's plus. So I get minus I1 times 20, and then I'm going from the negative to the positive side, so I get plus 1.5 volts. And then I come down here, and I'm going the same direction as I2, so I get minus I2 times 10. I don't know why I put a parenthesis there. Equals 0. Okay, so right here, I'm going to solve for I2. So I2 times 10 equals, add 3 to both sides, equals 3. So I2 equals 3 over 10 amps. I got that one, right? Both resistors. Find the current through both resistors. There's one of them. Now I need to get I1. So down here, I can say minus I1 times 20 plus 1.5. Now I2 is going to be minus 3/10 times 10 equals 0. So this is going to be just minus 3. I have 1.5 minus 3 is going to be minus 1.5. And I get minus 1 I120 minus 1.5 equals 0. So now if I add 1.5 to both sides, I can solve for I1. I1 is going to be equal to 1.5 divided by negative 20 amps. So this is negative, right? So that means that I got this backwards. So in fact, the electric current is actually going this way. So this battery is actually getting charged. But that's it. I'm done. Now, if you had done this big loop, it actually would have been a little bit easier because this equation would have had just this 3 volts and wouldn't have had I2 in it at all. The I3 doesn't matter. I3 doesn't matter because there's no resistor in there, so you can only see it in this equation right here. I can still solve for I3 by using these two currents and plugging them in there. But it didn't ask for that, so I'm not going to do it.